Assalamu alaikum students. Let's start with the name of Allah. Bismillahirrahmanirrahim. Today's our topic of class 10, Physics, chapter number 10, Simple Harmonic Motion and Waves. Today our topic is, first of all, I will discuss the term vibratory or oscillatory motion. If a body moves to and fro position about its mean position, this is called vibratory or oscillatory motion. In this chapter, we will discuss the special kind of oscillatory motion is called simple harmonic motion. Simple harmonic motion are those motion in which body is rotated about its mean position. So this is a special type of oscillatory motion. In this chapter, we will discuss the three examples of simple harmonic motion. First one is the horizontal mass spring system. Second one is the motion of a ball placed in a bowl. Third one is the motion of a simple pendulum. Today our topic is mass is attached to the spring on the horizontal frictionless surface. You can see in this diagram a spring that is attached to one end with the mass and another end is attached to the fixed point. This is a mass. If we put the force on this mass, then the spring is stretched. According to the Hooke's law, if we apply stress, then strain is produced. When we increase the stress, strain is also increased. So force, according to Hooke's law, force is directly proportional to the change in length x of the spring. So force is directly proportional to x. X is the displacement of the mass. You can see in this diagram x, this is the x and this is the force. Now by removing the proportionality sign, constant is applied. So F is equal to minus kx. Now we find the k value. K is the spring constant. K is equal to minus F over x. F is the force and x is the displacement. According to the second law of motion, F is equal to ma. Now putting the value of F in equation 1, K is equal to minus ma over x. So we find the acceleration. A is placed separate side and A is equal to minus kx over m. So K is constant and m is also constant. So we neglect these two constant. So by removing constant, proportionality sign is put. So A is directly proportional to minus x. Acceleration is directly proportional to the displacement of the mass. K is called the spring constant. The value of K is a measure of the stiffness of the spring. Stiff spring have large K value and soft spring has small K value. Minus sign indicate that force exerted by the spring is always directed opposite to the displacement of the mass. So spring force always acted toward the mean position. So it is called the restoring force. Now move toward your diagram. You can see that this position is O, is called mean position. A and B position is called extreme position. At O position, the mass m is at rest. There is no force is applied at this situation. So velocity is maximum at this point and acceleration is 0. Now we bring this mass towards the extreme position A. Now acceleration is maximum and velocity is 0. The restoring force act on this mass m bring back toward the O position. So restoring force always pushes or pulls the object performing oscillatory motion toward the mean position. The magnitude of the restoring force decreases with the distance from the mean position and becomes 0 at O position. Due to inertia, this mass is not stopped at this point. It continues its motion and moves toward the position B, extreme position. At this point, acceleration is maximum and velocity is 0. Force is also maximum. It rests for a while, then move toward the mean position due to the restoring force. So the mass is oscillate around their mean position. You can see that acceleration is always toward the mean position. So restoring force is always acting toward their mean position. Now discuss the energies of this mass spring system. At O point, kinetic energy is maximum, potential energy is 0 at this point. But at extreme position A and B, kinetic energy is 0 and potential energy is maximum. So these energies are interconverted into each other. So this is the simple harmonic motion of the mass spring system. Bodies oscillate to and fro about their mean position. So we can define the simple harmonic motion. Simple harmonic motion occurs when the net force is proportional to the displacement from the mean position and is always directed toward the mean position. Now we can calculate the time period of the simple harmonic motion of mass spring system. T is equal to 2 pi square root m over k. M is the mass of the spring system and k is the spring constant. Now we define the time period. The time taken by a vibrating body to complete its one vibration is called time period. Next, move toward second example, motion of a ball placed in a bowl. This is another example of simple harmonic motion. You can see in the picture there is a bowl and ball is placed in this bowl. The ball is present at point O. O is the mean position. A and B is the extreme position. At point O, ball is at rest. But at this point, two forces are act on each other. First one is the upward force and second one is the weight. Weight is act due to force of gravity. So force of gravity act as restoring force and upward force is the normal force of the surface that is act on the surface of the ball. At point O, net force is 0. When we bring this ball at point A, their velocity is 0 and the force is maximum. So acceleration is also maximum. Ball, due to inertia, ball continued its motion. Ball didn't stop at this position. It continued its motion and moved toward their B extreme position. At point B, velocity is 0 and acceleration is maximum. Force is also maximum. So ball rest for a while and then move toward their position, mean position O. Ball continues its motion until all the energy is lost due to friction. In this chapter, we will discuss an ideal system of the simple harmonic motion where is no friction and no air resistance is present. If the friction is present in the ball system, then the ball is stopped due to the energy is lost due to air friction. So ball continue its simple harmonic motion to and fro about in mean position. So restoring force in this diagram is act toward their center. Thank you. See you next time. Allah Hafiz.